Today I am going to talk about numerical differentiation. Now, what is numerical differentiation? Means what is the definition of numerical differentiation? So, if I plot, okay, so here numerical differentiation involves approximating the derivatives of a function at point x0 using the value of function at nearby data points. Different numerical differentiation formulas such as forward difference, backward difference, and central difference use different combination of neighboring data points to estimate the derivative. Does it mean? Now, if you plot x versus fx, means we plot function with the different x data points. So you will suppose you will get this type of function, a graph. Now suppose if suppose this point is x0, this point is x0 plus h, and this point suppose x0 minus h, and if you go to the corresponding graph, so you'll get the function value. Okay, using that function value, and we can do the combination and we can get numerical differentiation. So that is the meaning. So using different combination of neighboring data point to estimate the derivatives. Now, what are the application of numerical differentiation? So numerical differentiation finds applications in various fields, including scientific research, signal processing, optimization and root finding algorithm, and differential equation. So, and in chemical engineering field, scientific research and optimization and root finding algorithm, numerical differentiation actually used. Next, common numerical differentiation method. Numerical differentiation methods, here 4 numerical differentiation methods are there. One is forward difference, backward difference, central difference, and Richard extrapolation numerical differentiation method. Now here I will discuss 3 only: forward difference, backward difference, and central difference. Now what is forward difference? Now first try to I'm going to explain that. Now here if you plot that, again x versus fx, suppose this plot is like that. Now if you take this point, suppose this is x0 point, maybe this point is x0 plus h point, and this point may be x0 minus h point. Okay, now corresponding x0, if you draw the line, or if you go from x0 to that functional graph, so that will intersect here, means here you will get the function value, and that function value means at x is equal to x0. Similarly, if you again draw one line, straight line, and that will cut here, and again you will get one function value. So that function value is corresponding at x is equal to x0 plus h. Now here again, if you go to that function, again you will get another function value. So now, so here f dash, according to forward difference, f dash x is equal to fx plus h minus fx. Now if you take x is equal to x0, so that means x0, that means f of x0 plus h minus fx. So here h is the step size of, or the distance between 2 points. Now f x0 plus h means this value, okay, and fx means at x0, so this point. So take the difference and divide it with the h. We can easily get the differentiation by using forward difference. Similarly, backward difference, again take, so this is forward and this is backward difference, so we need 2 points, this point and this point. Again take the difference, so fx0 is here, this function value, and fx0 minus h, that function value is here. So take the difference and divide with h, so again we will get the numerical differentiation by using backward difference. Now what is the central difference? Central difference, again, so that formula is f dash x is equal to f of x0 x plus h minus f of x minus h. So if you take x is equal to x0, so that will be f x0 plus h, means function value at x is equal to x0 plus h, minus function value at x is equal to x0 minus h by 2h. Okay, h is that step size. Now here if you see here, so this is x0 plus h, corresponding function value is here, corresponding x0 minus h, corresponding function value is here. Now again take the difference and divide it by 2h, so you will get we can easily get the numerical differentiation at x0. Now here I am giving the table. In that table different formulas are given, different methods are given, and also formula for first order derivative and Tank-Kaiser error, means what is the accuracy of this method. So here 2-point forward difference method. So f dash x is equal to f of x plus h minus fx by h. So that is first order of h, means first order accuracy. And 2-point means only order of h, means as h is very small, if order is increasing means that is accurate. 2-point backward difference formula, so that is f dash x is equal to fx minus f of x minus h by h. 2-point central difference, f dash x is equal to approximately f of x plus h minus f of x minus h by 2h. And then 3-point forward, 3-point backward, and 3-point central difference. So if we have 3 neighboring data points, we can easily calculate numerical differentiation. And all this method actually called finite difference formulas. Now also another formula is also there, 3-point central difference by calculating second derivative, first order derivative as well as second order derivative. Here we are calculating the numerical value or numerical differentiation. By using this formula we can calculate second order derivative of any function, and in particular x value. Now here I'm calculating numerical differentiation by using 3-point backward difference. So I'll show you, I'll use 3 method and I'll show you what is the difference between the 3 method, means whether I'll get that similar result or different result. Now here I'm taking one example. I'm function, so that function is fx is equal to sine x, and here we have to calculate the first derivative of that function at x is equal to pi by 4. So at x is equal to pi by 4, what will be the first derivative of fx or first derivative of sine x? Now analytically we know, so analytically we can do the differentiation. So df by dx is nothing but d of dx of sine x. So that if we do that, so that will be cos x. Now df by dx at x is equal to pi by 4, so that will give 0. Or we can cos pi by 4, that will give 0.707, something like that. Now here I'm going to calculate differentiation by using 3-point backward difference formula. So what is the 3-point backward difference formula? So f dash x is equal to 3fx minus 4f x minus h plus f x minus 2h by 2h. Now here fx we know sine x, so 3 into sine pi by 4 at x is equal to pi by 4, so 3 sine pi by 4 minus 4 sine pi by 4 minus 0.1 plus sine pi by 4 minus 0.2. Okay, now if we calculate what will be the value of 3 sine pi by 4 minus 4 sine pi by 4 minus 0.1 or plus sine pi by 4 minus 0.2 by 2 into 0.1 means 0.2. So here that f dash pi by 4 we will get 3 into that pi by 4 is 0.707. Pi by 4 minus 0.1 is actually 0.6330, and sine pi by 4 minus 0.2, that value is 0.5525 by 0.02. We can check check that value whether I did mistake or not. Okay, so I think I did correctly. So now if we put everything, so ultimately we'll get f dash pi by 4 is equal to 7.096, and analytically we got that f dash pi by 4 is equal to 0.707. So you can see that result is nearly same. and our error is very less. Next, 3-point forward dependence. Similar way, so 3-point, remember that formula is important. So if you know the formula, you can easily calculate. If you don't know the formula, then you can't calculate. So formula is very important. So in the exam or anywhere, when you are calculating that numerical differentiation, formula you have to remember. So f dash x is equal to minus 3fx plus 4fx plus h by 2h minus fx plus 2h. Again, so fx is equal to x is equal to pi by 4 and fx is equal to sine. So sine by pi by 4, sine pi by 4 plus 0.1, sine pi by 4 plus 2.0.1 by 2h. H is actually 0.1. Now, so f pi by 4 is equal to sine pi by 4, that is root 2 by 2. Sine pi by 4 plus 0.1, so that will give 0.7728. F pi by 4 plus 2 into 0.1, so that will give 0.8370. Now if we plug all this value in that function f dash pi by 4, so that will give that 0.7093. so backward we got 0.7096. analytically we got 0.707. so you can see the result are very similar. Now next is very popular, so generally we use central difference, so that is the second order accuracy. So again, that central difference formula is here. Okay, so here f dash pi by 4 is equal to f pi by 4 plus h minus f pi by 4 minus h. Actual the formula is f of x is equal to f of x plus h minus f of x minus h by 2h. Okay, so here x is equal to pi by 4, so pi by 4 plus h minus f pi by 4 minus h, and you know fx is nothing but sine x. Okay, so sine pi by 4 plus h, sine pi by 4 minus h is equal to 0.1. so now here that f pi by 4 minus 0.1 means sine pi by 4 minus 0.1, so ultimately that will be 0.6274, and f pi by 4 plus 0.1 means sine pi by 4 plus 0.1, that will give 0.7728. now if we plug that value in that f dash pi by 4, so 0.7728 minus 0.6274 by 2 into 0.1, so that will ultimately give that 0.727, though it is giving that higher value. So forward we got 0.09, we got what value we got, that forward we got 0.93. forward we got 0.7093. backward we got 0.7096, and analytically we know 0.707. so you can see the results are not very different, results are very nearly same, or error is very minimum. So all these three methods are quite popular, so we can use any method and we can easily calculate the differentiation. So this is the one problem. And now okay, so again, so second order differentiation, so we can calculate again, so that formula is important. So what is the second order differential formula? So that that f double dash pi by 4 is equal to f pi by 4 plus h minus 2f pi by 4 plus f pi by 4 minus h. Again, that f pi by 4 means sine this one, f pi by 4 plus h means that f pi by 4 plus h means 0.1, pi x is equal to pi by 4, that's sine pi by 4, so that is again that value, that a pi by 4 minus 1 h minus that f pi by 4 minus h means sine pi by 4 minus 0.1. again we will if you calculate we get that value, and f pi by 4 is equal to root 2 by 2. If we plug all this value, ultimately we'll get that f double dash pi by 4 is equal to minus 700. now we can do analytically also, so d square f by dx square, that is f is actually d square by dx square of sine x, so that will be give that dy dx will be cos x and then minus sine x. so now we can put that at x is equal to pi by 4, now that will give again minus 0.707. now you can see that second order derivative is nearly same. And also that if you take that difference, so the difference also very small. So this is the one type of problem. Another type of problem I am solving here. So here the data points are given, so that x data points are given and corresponding fx data points are given, like x is equal to 1.1, what will be the function value 0.6133, like that. Now by now all these data are given. Now find the first derivative f dash x at x is equal to 1.3. Now here you have to, here what methods you have to use. So 3-point forward difference method, 3-point backward difference method, and 2-point central difference method, and also 3-point central difference. So find the second order derivative at x is equal to 1.3. Now so all our neighboring data points are given. Now I am going again, that formula is important. So what is 3-point formula? So 3-point forward difference formula is f dash x minus 3fx plus 4fx plus h and fx plus 2h. Now first x is equal to 1.3, then x plus h is actually 1.4, and x plus 2h is 1.5. okay, now corresponding that x value, x is equal to 1.3 this value, x point 1.5 this value, x point 1.4 this value. Now if I put that function value like f 1.3, f 1.3 means 0.9716, 0.9716. So that f 1.6, 1.4 means 1.1814, 1.1814, 4 into this, and f 1.5 means this value 1.4117, 1.14117. So ultimately we'll get all this. We plug this value, means we took from this data point, we get that function value from that already given in the given in the problem. From that we took that and then we plug all this value, and ultimately f dash 1.3, so that will be 1.9955. Similarly again 3-point backward difference. So here the formula is important. If you know the formula you can do that. So f x minus 2h, x is 1.3, 2h means 2 into 0.1, and then f 4f x minus h, x is 1.3, h is 0.1, f x is 1.3. so all these function value are given in the data points, and all this given data. Now if you plug all this, so again f dash 1 by 1.3, that is 1.9965. so it is nearly similar between that forward as well as backward. Now if I calculate first order derivative by central difference, so again, so f of x plus h minus f of x plus h, x is 1.3, h is 0.1, so f of means 1.4, that is 1.4 and 1.2. if you take that data, so that will be at x is equal to 1.4, the function value is 1.1814, and x is equal to 1.2, function value is 0.7822 by 2.01. so if we calculate that again, we'll get 1.9960. so again similar result we'll get. Means you can easily calculate any method, and you can use any formula, and you can easily calculate the numerical differentiation. Now 3-point central difference for second derivative. So again the formula is important. If you know the formula you can do that. So f double dash x is equal to fx minus h minus 2fx plus fx plus h by h square. So x is equal to 1.3. okay, x is equal to 1.3, h is equal to 0.1. so again if we plug, so we'll get f, that is 1.2, 1.3 and 1.4. corresponding value, a function value is this 1.3, corresponding function value is this, corresponding function value is this. And if we plug and if we do the calculation, after that we can get that f 1.3 is equal to 2.04. so therefore f 1.2 use 2.04 using the central difference formula for first, not first order, this is second order differentiation. So now you know how to calculate numerical differentiation, or how to calculate how to get the numerical differentiation value, how to calculate numerical differentiation, or and you also you can you know how to calculate first order differentiation and second order differentiation. So for especially when you use that Newton-Raphson method, so in Newton-Raphson method, you know Newton-Inner method, so we need, so that xn plus 1 is equal to xn minus f of x and f dash xn. okay, so if that fx is very complicated, so So that time we can use that this method, central difference or forward backward. Okay, and we can easily calculate any function. Even if we get even in the problem, if there is a very complicated function, so we can easily do the numerical differentiation by using any formula like forward backward as well as central difference. So that is means you must know how to calculate numerical differentiation. That's it. Next class I'll talk about numerical integration. So if you have any question, query, so you can post it here, or you can send the mail, you'll get the response. Thank you.